Okay, hi. First of all, it's not my fault that it's complex, but um, what do... yeah, I quite sometimes think if I read the specifications from the 3GPP, I want to have what they had when they was writing it, but unfortunately they don't sell me that drugs. What's our today's schedule? First of all, I want to make a quick walkthrough through the basic infrastructure. And I want to give some short background on IMS on Kamailio. I know we are a little bit late and we all definitely need coffee, so I try to make it quick. What I want to do is to do a real-life installation of all the necessary network components that are available as open source. We're going to deploy a proxy CSCF, which is basically the entry point to the network. We will deploy an interrogating CSCF, the serving CSCF. We will even deploy a home subscriber server. And basically, if time allows, we will even create a maybe a simple application server based on Kamailio. Okay. First of all, I guess you've all know this picture from last year. This is basically our infrastructure. We've got a proxy CSCF, which is some sort acting as a gateway, as some sort of a firewall. Normally, we would also deploy an RX interface, which is the interface towards the packet core. So we could do some quality of service agreements, stuff like that, provide some priority, stuff like that. And, but we will not, in this live installation, we will simply keep the RX interface out of the equation. Then we've got the interrogating CSCF, which is some sort of intelligent load balancer. It's connected to the home subscriber server, and it will, will query the home subscriber server for location information, and so the interrogating CSCF can forward the request to the according serving CSCF. The serving CSCF is the worker. This is the endpoint where user agents register. And it's also the component that will actually trigger some rules which will forward your zip request to maybe an application server or do anything else what you want to do with the application. It's again connected to the home subscriber server via diameter interface in order to exchange authentication information, in order to exchange service profiles, stuff like that. The serving CSCF also has a charging interface because most services in the world would be not really interesting if we would not have any charging, at least from an operator perspective. And of course, we will always have some sort of interconnect to other networks. Just a few words on IMS on Kamailio. IMS on Kamailio is based on Fraunhofer Focus Open Ims Core. We basically took all the components that were available in the Open Ims Core, imported that into the Kamailio tree, basically changed, apart from the diameter peer, almost everything. And we did very huge efforts in terms of performance, stability, scalability. And everything that we need to build a testbed is available as open source. Most of the things I will do live, but there was one thing that I had to prepare a little bit in advance. And that's a very important part. That's the DNS part. We've got a DNS domain, kamailio.ims.org, and we need to define what services we are providing on that network. So we had to define the DNS zone for that domain. So So we basically have all these NA-PTR records, which will indicate, for example, Kamailio IMS org will support a zip on UDP, which will have a lower priority than, for example, ZIMP via TCP. If you do IMS, DNS is always a really, really important topic. Basically, in any case, in anything we do, we use all kinds of SRV records. For example, we also have NA-PTR records to indicate what services a specific component is talking, what ports we are using. For example, we are using 4060 for the proxy CSCF, 5060 for the interrogating CSCF, and so on and so forth. So we use DNS quite a lot. As soon as we add some external interconnection, we also have to add enum lookups. We need enum lookups in quite a few places. Okay, so now let's get started. It's really IMS as a topic is always considered quite complex, but in fact it's not that bad. For installing an IMS core based on Kamailio, it's really a few steps. Here we go. So we have as a basic requirement that we need a pretty standard Debian 7, 64-bit, because we do all our packages in 64-bit. Where's my mouse? There. So all we need to do is basically add our public key. We need to add our repository, hit get update, and quickly install some packages. If anybody wants to try this at home later, I've got all the configurations, all the slides, all the documentation available as a download, and otherwise just ask me. Okay. Oops, here we go. Okay. Yeah, install a lot of packages. Okay, what are we installing? We are installing a Mysql server, pretty much straightforward. We are installing the Open IMS Core home subscriber server. We give our domain a fancy name. We've got Kamailio-ims.org. That will be our domain name. As we are using a public DNS server, we can just enter a standard DNS name here. Oops. Yes. We don't want to extract extra users. Start automatically, and then basically it goes. Takes a while because it's basically downloading the internet. Okay. Okay. So while it's installing, we can. What do we need in our Ims Core? Of course, we need a Zip Express media server. This is basically because we need to do the standard requirements requires us to support AMR narrowband minimum, maybe even AMR wideband. And as soon as we want to connect to a pretty much straightforward application server, we need to do transcoding in the network. So that's why we need to deploy XAMPP, which acts perfectly for transcoding. After the installation, we pretty much just have to modify a few parameters, which is, of course, we want to run XAMPP, and we need to define one single IP address mapping, which is basically the IP address of our proxy CSF, which will be the same as XAMPP. And we need to send requests coming from that particular IP address to one certain profile. A very important note on AMR narrowband. Unfortunately, and I don't know what hits them, AMR narrowband is patented. So if you want to run a VoLTE service, you need to get a license agreement. Unlike, for example, G729, with AMR narrowband, this is rather, I would say, almost complex, because you have to get a license from Ericsson, from Nokia, Siemens, from NTT, and you have to basically make an agreement with all of them. On the proxy CSF, as the first component, we not only deploy XAMPP for transcoding, but we also deploy Zipwise's RTP engine. And again, for the RTP engine, we really just configure pretty much standard things that we want to run the RTP engine and that what interfaces we want to use, stuff like that. Okay, let's see how our installation goes. Okay, no. Yes, we agree to Oracle. For the setup and configuration of the Ims Core, we tried to make everything as simple as possible. So instead of really editing and changing everything, we decided to really separate the configuration files. So on the one hand, we've got a rather complex Kamailio configuration, where we do a lot of if-defs and stuff like that, and where we basically handle all the standards. And on the other hand, everything that's pretty much more specific is in a separate configuration file. And in this specific configuration file, we have stuff like how many processes we want to have, what are the IP addresses, what are the ports we're using, network names, all kind of stuff. What is our database connection? We've even taken it so far that we can actually work with several databases at once. Once we define a second database connection, we will deploy it as a DB cluster connection. Really, really a lot of things. Even if you wanted to deploy more than one RTP engine because we're running high traffic, or if you want to deploy more than one SBC because transcoding software base always takes a lot of resources, we can simply add this to our proxy CSCF. Okay. We did something wrong in this menu, but it doesn't matter because we just have to change. Yeah. Okay. Great. We just need to. Okay. Just a moment. As always, it helps if you read what you type. And we need to have the HSS properties. Okay, there it goes. That was it. Okay. So now we can actually continue with thems. We first take the etc default thems, and we just change this here to yes. Let me take a second. And then we just take in the prepared configuration I did. All I basically did was to modify this single line, where I just added our own IP address with our own port that we want. If it's coming from our IP address, our proxy CSCF port, we want to send it to the mobile originating SBC profile. Yeah. XAMPP itself, in this configuration package, is configured that it will listen on the first network device. It will basically listen on ETH 0. Okay. So back to our machine. That's the wrong machine. So now we should have service them start. Okay, it started. In GCP, etc default in GCP RTP engine and oops. That's the file. We want to have an interface here. That's basically all we need to change. And we just say, oops, we take our IP address again. So this GCP RTP engine start. Okay. So the next thing we're going to do is we're going to add a specific, since on this single machine, we will have at least, really at least, 3 different Kamailios running. In a normal setup, you would, of course, separate that onto different machines. You would probably have one proxy CSCF, which, if I would build a mobile network, then I would have probably a proxy CSCF for each part of the country, and not a single instance handling it all. If you look at a typical mobile operator network, then you even have the Ims Core itself distributed among different sites. For example, the German O2 network, when they started doing IMS and voice over LTE, they had it on 2 sites. I think by now they even deployed it onto more sites. So this is really basic, just a starting point. Okay. So, okay. And again, this is just okay. Also, this SQL file is basically just pretty much standard MySQL dump, where I've just added some create, use, and grants at top. So nothing really spectacular. If you wanted to really run this on a separate machine, you could, of course, use the standard Kamailio tools like CamDBCTL to create the according databases. But it's really, really much straightforward. Okay. Okay. So now we've got our first component running, which is the proxy CSCF. It's really, of course, it's always work setting up an Ims Core, but it's really just about modifying a dispatcher file, adding the IP address at some defined spaces, and about creating a database. Okay. The other components are pretty much the same, and I could basically repeat what I just did 3 times. Again, it would be just modifying the interrogating CSCF configuration, which again would contain IP addresses and a database connection. But this time we would also have to modify the ICSCF XML, which contains the diameter connection. The diameter connection is also pretty much straightforward. We have to define a realm, Kamailio.ims.org, for example. We have to define what's our peer, what realms are served, on what ports our diameter peer is listening on. We have to define what local ports we're using. In this time, since we've got the HSS and all the other IMS components on one machine, we would have to use a different port, but okay, we can simply define that. And what makes it a little bit more complicated is that we also always have to define what applications we are supporting. In this particular case, we are only supporting one specific application, and that's the CXDX application, which is defined by the 3GPP. If we have other components, like for example the proxy CSCF or the serving CSCF, we can have a whole bunch of applications that are supported. For example, on the serving CSCF, we have, of course, the CXDX interface towards the home subscriber server. On the other hand, we will have the charging interface, which is RO, which is a different vendor, a different application. And so we have to announce that in our diameter connection setup. The idea behind this application definition and this application definition in diameter is that I've got different servers which support different applications. We've got, just to give an example, if I would have CXDX at maybe RO for online charging, and if I would connect to a different peer, like this one, for example, then the peer will answer me, okay, I support CXDX. So if I want to do a CXDX request, give me your CXDX request. On the other hand, if I have a second peer, which I only use for charging, that peer would answer me, okay, I'm supporting the online charging. So on this way, you have different peers negotiating with each other what applications are supported. We can also do some load balancing in this configuration file. In this simple example, of course, we only have one route for our realm, which is our one and only home subscriber server. If you look at implementations of home subscriber servers, you will see that most of the stuff that is done on a home subscriber server is pretty transactionless. So I send an authentication request that I get. It doesn't really matter if I send the second request to a different home subscriber server because it will basically know what to do with it. So that's very easy load balancing at this part. If I look at something different and something more complicated, then it's a bit more complicated. For example, if I look at online charging, then of course I have to send the initial request for my credit reservation to the same charging server that I will send the final credit request. So, but for CXDX, this works just perfect. For RO, the charging module of Kamailio, we did some enhancements so we could actually even split that. But there we have to go to a specific charging server again. Okay. Okay. Again, for the serving CCF, as mentioned, this is pretty much the same as on every single component we have in our Kamailio setup. I don't know, I can of course install it, but it's really pretty much straightforward. Wait. Okay, it's 2:30. So I guess I just have the time to quickly install it. Because once we've installed the proxy CSCF, the interrogating CSCF, and the serving CSCF, we can actually register within our network. We can take a very basic zip client, and we just have we can simply register. All we have to take care of is that we have to use an authentication username, and but that's pretty much it. If the client properly supports NAPTR, if it doesn't support NAPTR records, then we have to define an outbound proxy, but that's purely optional. If I look at our mobile network, this definition of the outbound proxy is actually done during the LTE handshake. So we've got a construct which is called PCOs, which is pushed configuration objects, I guess, where if I have a mobile phone that will register to a mobile network, it will get in the reply from the eNode B what particular outbound proxy it should use. This is basically because depending on my location, depending on what cell I'm currently connecting to, I want to use a different outbound proxy. And I don't want to have a single outbound proxy because it's all a question of flexibility. For example, if I would have a centralized IMS installation in Frankfurt or somewhere else in the world, then of course I don't want to have all my RTP relaying first going to Frankfurt, then going back maybe to another guy here in Berlin where I'm making a call, and also if I want to do this quality of service assignments, agreements, then anyway I have to talk to my mobile network here, so why first send it around the world? Another topic where this comes in handy is, of course, all this roaming topic. If I'm in my own network, of course, I can always talk to my own network. But as soon as I enter a different network, let's say I have my own LTE network in Hamburg, for example, in Germany, and now I'm in Berlin and I want to do roaming, then of course I have to use the proxy CSCF of my roaming partner. Because all this quality of service assurance, all this quality of service agreements has to be done by the roaming partner because he controls his network. So that's basically why it's really done dynamically. The next thing what we want to do is, of course, we want to interconnect. Well, after we've set up all the interrogating, all the serving CSCF, it would be kind of boring if only our internal users could speak to each other. So we need to add some external interconnect. What is a little bit different from probably other implementations is that we have a different signaling path for originating calls or calls coming from the other networks to our own network, and for the calls coming from our network going outside to the other network. All the inbound calls need to be pointed at our interrogating CSCF. The interrogating CSCF can then query the home subscriber server, can determine what serving CSCF the user is registered on, and then send it to the according serving CSCF. On the other hand, if I want to make an outbound call, the serving CSCF will basically send it directly to the destination party, to the destination gateway. For inbound calls, we basically don't need to define anything specific on our interrogating CSCF. We just have to open the firewall, so it can talk to our Kamailio sitting at the interrogating CSCF. For the outbound traffic, this is a little bit different. There but it's nothing really black magic in there. We just need to add that to the dispatcher list. And we have a specific group on the dispatcher list, so it's add your IP address, go ahead, have fun. But there's always a little bit but involved. In this case, as soon as we want to work with PSTN interconnects, we will likely need enum. Because if I have my mobile number registered in my network, then of course I could, take my spoken username, like for example Carsten, and if you call Carsten, you would call me directly. But if you would dial my mobile number, then I have to make a certain mapping between the number and the specific user we're talking to. And in that case, we definitely need enum. Okay. The next thing we want to do is we want to add applications. Because right now, with this basic setup, we can basically make calls if we dial in the right style of number, probably, and if we dial the right username. But maybe we want to add more applications to our network. An application can be anything. It can really be anything. Like, for example, we had this example with the dial plan in the Zipwise presentation, like an hour ago. That could be, for example, be a typical application we want to add to our network, where we would say, okay, if the user dials 0179 something, then we want to change that dial number into something that is more international, that everybody understands. Also, for example, if we want to have, for example, if I get called, maybe I don't want to see +49179 because I'm expecting something else. For example, something like that. Or, for example, I want to do an application that will handle call forwarding. It's really pretty. This is something that is not handled by the Ims Core because that's, according to the Ims specification, is an extra application. Or something like adding an announcement in case I don't have enough credit. Or I want to have voicemail. Anything, really anything can be an application. It can be like video conference, really anything. And the really important thing here is that it just have to speak zip. So we can use FreeSwitch, we can use Asterisk, we can use Kamailio. An application is defined in an Ims setup by defining trigger points. A trigger point, just let me get an example. This is a standard web interface of the home subscriber server with some standard credentials. Waiting. Yeah, whatever. And here we've got our service configuration. Each subscriber has assigned a service profile. The service profile basically defined what kind of services are available to the specific subscriber. And here, of course, then you see that we've got some initial filter criteria. And here we've got our trigger points. And the default trigger point is something like this. We've got a specific zip message, which in this case is publish. We want to check for a certain header, like event, and this could be presence. And we want to have an originating session. So it's a request coming from the user towards the network. Or we want to have a publish with the event presence for an originating subscriber which is in the unregistered state. And this is basically how you make the rules in an Ims network. And you can really do a lot of different things. For example, in my talk about short message service for VoLTE, I'm doing on Friday, we will have a trigger point which will be a message and a zip header which would be content type 3GPP SMS, for example. And in that particular case, we want to send that to an application server. Everything is linked with the application server's point, where we basically say this application server should be triggered if this trigger point is working, is hit, if this trigger point is matching. Okay. And as I said, anything that speaks zip can be an application server. So I made a little really simple application server based on my Kamailio, which does, of course, some basic stuff like is the message valid, is all this standard stuff that you would do in a Kamailio. And of course, we need to handle requests that are within a dialog, but maybe even not, because we're not even doing loose routing on this machine. So all our application is doing here, we're checking the request URI. If it's starting with a 0, then we strip the 0 at prefix 49. Really, it was the simplest thing that I could imagine doing on an application server. And the only thing that we have to do on our application server as a Kamailio is we have to evaluate the route header that we're getting from the IMS network. The route header will contain basically what is the next hop for my request. So after doing all my manipulations here, it's basically just do loose route to relay, and we're done. And this one would be an application server that actually would even send the request back to the IMS network. But we could also do different stuff. Right? For example, if we want to do a presence, then we could handle this publish, or handle subscribe, notifies. And at this point, the application server would be an endpoint. In an IMS standardized architecture, an application server can either be a back-to-back user agent, if I want to use a free switch or asterisk or some sort of SBC, for whatever reasons I don't know. Or it can be a proxy, just like this, or it can be a zip endpoint. Those are the three typical application servers that are defined within the standard. Okay, that's about it, I hope. You will set up an Ims Core and report as many bugs as possible. Everything that I've used for this live walkthrough can be found, including the presentations, including what you need to install, can be found in a downloadable zip file. So it's basically just exchange the IP addresses, install the systems, and have fun. Okay. Questions? Okay.
How many computers you use?
This one was basically running just on one simple DigitalOcean instance. Yeah.
Okay, so it's easy to deploy.
It's easy to deploy, yes. It's really, really easy. Yeah.
I know maybe that's a long question, but what about LTE? How does IMS fit into the LTE?
IMS is the standard voice architecture for LTE. So let me get an example. Depending a little bit on the network, or depending a little bit on the SIM card. For example, good point. Wait. If I take my users here, for example, Alice and Bob, you would, for example, we use basically the same authentication methods as for the LTE network. So we basically do this lineage algorithm in the network. And so what you basically do, as soon as you plug in your SIM card, it will register within your home network for the data bearer. And it will use the authentication methods provided by a SIM card to make this zip registration. Of course, you can manually configure it, but who really wants that? Because it should be plug in your SIM card and make your call. It takes authentication from the SIM card. The network will also provide information like, for example, what kind of voice service do you want to provide? Should it be packet switched like IMS, or should it be circuit switched like 3G and all the crap that was before? Also, what really makes a huge difference is that if I use voice over LTE and LTE as such, then of course, since this is basically running on the core of your LTE modem, it's not like an application you are downloading. It's something that really runs in the core of your mobile phone. It really costs very low resources. You can even switch off mobile data because your LTE modem will still be connected. And what really makes a difference is quality of service. I had this in my presentation just pretty much at the beginning. Here we go. If I take my standard application, for example, I use my Google Nexus 5, which is a little bit crappy by now, but doesn't matter. I'm using Zolper as an application for making voice over IP on my Google Nexus. The really difference is that the data network that I'm using on my Nexus 5 here, since it's not really VoLTE, it's using a best effort network. Really best effort. Like, if the cell is totally booked, yeah, good luck with your call. As soon as I use VoLTE, my call will go through my proxy CSCF. The proxy CSCF, as such, will extract all the information about the media streams, will basically announce to the packet core that we've got following IP addresses, following ports are speaking to each other, what codecs are we speaking to each other, do we want to make audio, do we want to make video? So the packet core can, for example, say, okay, this cell you're currently in is pretty booked, so maybe don't do video. Not a good idea. It will terribly fail. On the other hand, if you want to make a standard voice call, yeah, you're my good customer, you're paying me, so you get best quality I can offer you. So I've really got the best quality of service experience that I can provide to the user, and that's really the huge difference. Yeah.
It's more like connecting the link layer with the application layer. When you do like a VoIP application, it's voice over IP. The link layer, it's Ethernet cable or the normal IP connection, you have DSL. Here, the LTE is the link layer with the waves, and IMS is the platform for routing voice through the IMS, controlling the quality of the service. So we'll connect to this cell and we'll say we have a call now. Forget those guys that do YouTube watching or Mercat or whatsoever. They will decrease their bandwidth and will give you bandwidth for your call.
Yeah.
That will be the difference. If you do voice over IP call, like he said with Zoiper, it goes like the other guys watching YouTube and so on, so you compete with them. With IMS, practically you have, or the provider can ensure quality of service for you.
Yeah.
Other questions?
From what I've heard from now from VoLTE users is that they were most of the time complaining about the voice quality. What I've read about the codecs is that the codecs used in VoLTE offer at least the quality that we have in GSM right now. My personal suspicion is that it has something to do with coding. Can you confirm this or not?
I some sort of can confirm that. If I have two VoLTE phones talking to each other, of course we can do AMR wideband and have great call quality. But as soon as I leave my network, technically speaking, I could do like AMR wideband to G722 transcoding because, for example, Deutsche Telekom in Germany will support G722 in their fixed line network. But it always really depends on your interconnect, on your destination. So at some point, if we leave our network, we have to do transcoding. So yeah. On the mobile network, there are some really, really interesting and exciting developments. We're talking about wideband audio right now, which is already pretty good, but we are currently working a little bit in a project where we're doing full HD audio on the mobile handset, which is totally amazing.
Okay.
No, it's only between VoLTE handsets then, in that case, of course. Yeah.
Okay, so if no other question, because Carsten will be with the exhibition spot outside, so you can stress him all next 2 days apart when he's speaking again. Other colleagues will be also around from Carsten and interesting show. For now, let's take a shorter break than expected. We are a bit behind with the time, but anyhow, we can use this room for the night. The only constraint we have to lock it, so you can sleep here. Okay, thank you, Carsten.